Hi, my name is Ariana Rodriguez, and this is 2D Fluent Flow Project 1 for Professor Osbe in Fluid Mechanics. So in this video, I'm going to cover Couette flow and the combined Couette and Ozol flow. So here is our workspace, and if you want to start fresh, Fluent Flow Fluent, we're going to click and drag. And so here you can see this kind of establishes the process we want to go through. So each question mark is one that we haven't done yet. And once completed, it'll turn into a check mark. So you want to start by clicking geometry, 3D, it's going to be changed to 2D. And then you want to right click geometry. And here I'm going to do new design modeler geometry. Perfect. So I'm going to click the Z axis facing me and then sketching, going to make a rectangle. I'm going to start at the origin and drag out. And then I want to set our dimensions. I'm going to make the units millimeters. And then for this project, we're given the guideline of L equals 150 H. So I'm going to establish my vertical height and my horizontal. And following the guideline, made my height 15 millimeters and my width 2,250 millimeters. Perfect. It's a lot smaller. So if I zoom in, you'd be able to see the rectangle. And then I just want to clear this here, but this is where you would display the units if you wanted to. Awesome. So now I'm going to go to box select. So I'm going to select our box and then create, was it concept? Surfaces from sketches under concept. I want to apply what we currently have selected, and then I'm going to click generate to generate our geometry. And you can see that it is now colored in. It has generated that geometry. You can see part one, body one, perfect. So I'm going to close this. And now we can see geometry has a check mark. Now we're ready to move on to meshing. We don't need to change anything over here. I'm going to double click mesh to open that. Awesome. Wait, perfect. There it is. And so want to make sure we're doing edge select, and we're going to start by just naming each piece that we have here. So I'm going to click name selection and then click top, control. Okay, I see. So I'm going to click the edge and then you want to right click where you want to name your selection. So click select and then create name selection. So I'm going to call this upper wall. I'm going to click, right click, create name selection, lower wall. Click, right click, inlet. Click, right click, outlet. Okay. So you can see here we have all our name selections. I can delete that one. Perfect. Okay. And then we are going to want to go to mesh, insert, sizing. So now we're going to want to select the upper and lower wall, hit apply over here, want to change the element or the type to go by number of divisions instead of element size. And then for number of divisions, I'm going to do 2,500. Capture curvature is no, and then behavior hard. Wonderful. And then we would just click generate, and that is going to make the mesh. And this takes a little bit, so I'm just going to pause the video real quick. So our meshing here is complete. So we're going to do the same thing for the inlet and outlet. So insert sizing. I'm going to click on the inlet and also click on the outlet. I'm going to apply the geometry. I'm going to do it by number divisions. And then for this one, I did 25. Capture curvature, no. And then behavior becomes hard again. And I'm going to hit generate. Great, so both of our meshes are done. And if I click mesh, it's black, but if we zoom in, we can see our mesh. And next we would want to do face meshing. We want to select everything here, hit apply. Perfect, everything looks good. And generate. Awesome, so now if we select mesh and zoom in, you can see our, our rectangular elements. So now we are done with the mesh, so I can close out of here. Awesome. And now I'm going to right click where mesh is and select update. Takes a little bit sometimes. It's a little slower on my computer, but I was able to add the progress bar here, so it's kind of showing me. Wonderful. So now, next, I'm going to set up. I'm going to change this to double precision and then double click setup. And it's going to ask again. For here, I'm saying double precision, and start. So at the moment, we can see down at the console, it's kind of just loading in each piece that we've made. So it has the wall faces, the inlet, surface body, yeah. And once that's all done, then it'll let us make the edits. Perfect. Close this window. I should just select it up. See this message again. There we go. All right. So we're going to start here at the top under models, right click viscous. Oh, I guess I can just double click. We want to change this to laminar flow. Okay. And then under materials, fluid, air. This is where you would change the fluid type and establish your density and viscosity. So I'm going to keep the density of air to be 1.225 kilograms per meters cubed. But for my viscosity, I'm going to say it's 10, 10 to the negative 4. Oops, cool. Change and create. Just want to double click that again. Close. And then under boundary conditions for the inlet, it says it's velocity inlet, but for Couette flow, we want to set the type to pressure inlet. Perfect. And we want to prevent reverse flow. By close. And then for the outlet, we want to also make sure that we are preventing reverse flow. And for Couette flow, in this case, we have the upper wall moving in the positive x direction. So I'm going to select upper wall to look like that. And I have it moving at 0.06 meters per second. So I'm going to change from stationary wall to moving wall and 0.06 meters per second. And want to make sure no slip condition is selected. Apply and close. And for the lower wall is going to remain stationary. So I just want to make sure that that is selected. Stationary, no slip. Perfect. So we are looking in good hands. And now if I go to the reference values, just want to confirm that I'm computing from the inlet. So we have our density, our viscosity, perfect. And the reference zone is a surface body. Great. So now we have everything set up. I'm just double checking to see if there's anything else I could be missing. Just wanted to confirm our fluid is air. Wonderful. So now I'm going to run the initialization, initialize, and it usually goes through 10 iterations. Perfect. Now I want to run the calculation and says 0, but I'm going to change that to 300. And I've seen it be anywhere from 150 to 500 iterations. So I'm going to hit calculate and then I will pause the video and come back once it's done. So our calculation is complete. So I'm going to hit OK. And I'm just going to minimize this window. So you can either close out of each window when you're done or just minimize them. I like to keep the setup still open just in case when I go to my results, if I want to tweak anything from there. And now I can open my results. Perfect. I'm going to click Z-axis and I'm going to insert different locations that we're interested in. So for this assignment, we want to know certain points, or we want to know the velocity at the midline as well as the end. And I'm also going to include a developing region just to help us further understand the flow. So want to go to location, I'm going to insert a line. I'm going to call the first one the midline. So we said that our the length here is 2,250 millimeters or 2.25 meters. So to do the midline, I would go at 1.125, which is the middle. And then I'm going to make the height 0.015. I'm going to do 100 samples, apply. So we can see that it applied it. That is our line that is at the center. That is our midline. I'm going to go back to location. I'm down another line, and I'm going to say that this one is the end line. I don't want it to be right at the end, but I want it to be really, really close. So we said that our whole length was 2.25 meters. So I'm going to do 2.2499. 2.2499. And again, the height is 15 millimeters, 100 samples. Apply. So we can see the yellow line there. And then I'm going to do one more line, which will be our developing line. And I'm going to make it just really close to the start. Again, the height. Awesome. Actually, let me make it a little closer that way. Perfect. Alrighty. And then I'm going to add contour. I'm not sure why that closed on me like that, so I'm gonna just double click. I hope it saved on my lines. Just give me one moment. I'm going to add those lines right back in. Alrighty, I have added my lines back in. So you can see them here. And then I want to add a contour. I don't know why it keeps doing that. Maybe it doesn't like that I have this open at the same time. So I'm just going to close this and redo that process again. Okay, so I'm going to insert. I've added my lines back in. Insert contour. Perfect. I'm not sure why it wasn't working before. I guess it maybe just didn't like the other window being open. Um, but location, I'm going to select symmetry 1, so I want the contour of this whole area. I want the variable here to be velocity because it's a velocity contour. I'm going to do 110. Perfect. So now I'm going to hit apply. Wonderful. And this label is in the way, so I'm just going to move it. Horizontal, appearance, fixed. Great. So now we can see our values. They're no longer in scientific notation and they're just horizontally above. And if we zoom in here, just intuitively, we can see that this makes sense. The velocity is highest at the top where the upper wall is, and we established the upper wall to be moving at 0.06 meters per second, which aligns here. This is saying that the highest velocity is 0.059 meters per second. Great. And now I'm going to insert vectors so that we can see it drawn a little bit better. So I'm going to go to Insert, Vector. I'm going to just do the midline because that is going to be easier to see, easier to visualize. Production factor, velocity, and then I'm going to change my production to coordinate frame, and it's going to be X. Perfect. Colors. Awesome. I'm going to hit apply. In order to see it a little bit better, I'm just going to turn the contour off. But here we can see that each line would be essentially an arrow. Move this. And it follows the behavior that we expect, which is linear. So it's kind of curving linearly. So now I want to insert a chart to, again, better visualize this data. So I'm just going to click right here for chart. Awesome. And then we can select, I'm going to name this velocity profile for Couette flow. Data series, I'm going to call this one at midline, as well as inline, and then developing region. But I'm just going to do these two first. And then I'm going to make the variable for x velocity u, and the y is going to be y. So I'm going to hit apply. Perfect. So we can see here that our end line has fully developed. It's fully developed and linear, and the midline is still developing, so it's kind of still having that curve, but it's going closer to being linear. So now I'm going to add the other data series for developing to see what that looks like. Okay. And it overlaps directly with the midline. Awesome. And if you want to export, you would click export, and it would show you the velocity u and velocity y, and it separates into two columns, and that can help you find your maximum velocity and the location that it occurs at. So now we are done with Couette flow. I'm going to show you how I did the hybrid flow. So I'm going to just go over here. The geometry and mesh follow the same process, except for my hybrid flow, instead of a height of 15, I do a height of 10 millimeters, which makes the length 1500 millimeters. So instead, I'm going to jump to set up and go through that process just to demonstrate what makes it different from the Couette flow I just displayed, or I just walked through. So it just takes a moment to load up. You can see here that it's calling on different parts of the mesh that we created. Awesome. So we're going to start again at models. You want to double click viscous and make sure that laminar flow is selected. So I'm going to hit OK. Close out of that. For the materials, I'm doing air again, and I've made the density 1.225 kilograms per meters cubed. So it's stayed that same throughout. And the viscosity here is the same as prior. So it's 1 times 10 to the negative fourth kilograms per meter second. So I'm going to change and create, close. So for our boundary conditions for the inlet, for Couette flow, we changed the type to pressure inlet, but for combined Poisson and Couette, we want to make sure that velocity inlet is selected. And for the outlet, it stays as a pressure outlet. So for our lower wall, we want to make sure that it's stationary with no slip. And then our upper wall, we gave a velocity to, and we made that 0.5, also no slip. And just to backtrack briefly, just to confirm this, you want to make sure that for outlet prevent reverse flow is selected. Perfect. I want to go to my reference values, and this is at the inlet. Our velocity is going to be 0.75 meters per second. Everything else agrees with what we put in. Surface body. Perfect. So now we would initialize and then follow the same process, run our calculations. I did this one again at 300 iterations. So I'm going to close out. Okay. Perfect. I'm going to go to the results. Let me add my contour and I'll show my vectors after. Actually, let me take it a step further. So I have my lines. I added a midline, an end line, and a developing line. I created the contours so we can see here what that's looking like. And then added the vector at the midline so we can kind of see it's following what we were expecting, where it's a mix of almost like parabolic, it's a superposition of the parabolic profile of the Poisson and the linear profile of the Couette. So it's kind of following the parabola and then it stops there. So that's that superposition that we're seeing there. And if I select my chart, here it is. And the developing region, the end line and midline are all overlapping. So if I delete, apply, you see that, apply, we can also see that. So again, I just followed the same process I did before. I added my midline, end line, and developing region. Considering my new dimensions, I added the contour. So let me just go to that. For symmetry 1, velocity u, my vector, which was at the midline, velocity, that all is the same. And then for my chart, I made my data series. I had my midline, endline, and developing that were all overlapping. So I showed you how if I delete each one, you can see where each one sits. And then the x and y axes, velocity u for x, y for y, and I would hit apply, and then you can export to save this data in an Excel sheet. Well, anyway, thank you so much for watching me explain the Couette and the combined Couette-Basalt flow. I hope this was helpful.